Hey everyone, welcome to the Unit 1, Section 5 Angle Relationship Notes. In this first section here, I'm defining adjacent angles for you. That's going to be two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So, what does that mean? Examples, a couple of examples of adjacent angles. Angles 1 and 2 are adjacent angles, okay? You can see angle 1 here is formed by these two sides, and angle 2 is formed by these two sides, so they have this side in common, okay? And then you could redraw those two angles, and they would have a different side in common. Angle 1 on the second one, angle 1, you could say it's this, 1, 2, 3, these 3 points. So it's using this side and that side, and angle 2 is this side and that side. So what side do they share? They share this side, okay? As long as they have a common vertex, which is that central point that forms the angle, right? So this is a common vertex here, this is the common vertex here, and then as long as they share a side, they're adjacent angles, okay? So here are some non-examples next to it. It says angle 3 and angle ABC are non-adjacent angles. So here's angle 3. So to explain this, I'm going to write a little 4 right here. Angles 3 and 4 are adjacent angles. They do share that common vertex point B. But because angle 3 is inside of angle ABC, it's encompassing the entire angle, it's not considered an adjacent angle. And in the second diagram, you can see that angle 3 is completely disconnected from angle ABC, and that's why those are non-adjacent. So in this box on the side, I just want you to write 2 key points for adjacent angles, and that's they have a common vertex and a common side. Our next piece of vocabulary is a linear pair. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So, examples 1 and 2 form a linear pair. So, opposite rays are a straight line. So, like this ray going that way to your left, and this ray from that dot going to the right, that makes an opposite ray, and it makes a straight line. A straight line makes 180 degrees. So if it makes up 180 degrees, you have opposite rays. You can see in this non-example, yeah, the rays are going in different directions, but they're not making a straight line. So they're not opposite rays. I guess you could say they're just intersecting rays. They have to be perfectly straight, okay? So for a linear pair, the 2 key pieces of information are that they are formed by adjacent angles and that they share a flat line. Next, we have vertical angles. They are 2 non-adjacent angles formed by 2 intersecting lines. Okay, so I just call these like X angles. And so the top and bottom of your X, those are vertical angles, angles 1 and 2. And then your sides, left and right, those are also vertical angles. Okay, um, but angles 1 and 3, those would be a linear pair, like 2 and 4 would be, because they're on a straight line and they're adjacent angles. Um, so your non-example, you see how there's a bend here? You need 2 straight lines. This line is fine. If this line were straight, I would have a picture like this one. But because this line is bent, it does not create a vertical angle. So the key pieces of information for vertical angles is that they're formed by intersecting lines and that they share a same vertex. So example 1, we're going to use this picture here, and we have a picture of these cheerleaders, but they're forming, it's kind of hard to tell, but kind of an X of sorts, but there's also these smaller angles there, okay? We're going to name an angle pair that satisfies each condition. The first condition is what are named 2 acute adjacent angles. So acute angles are angles that are smaller than 90 degrees, and adjacent angles we said that adjacent angles have a common vertex and a common side. So I'm looking at LJM, and then also I can say angle MJN. Okay, so LJM and MJN are adjacent acute angles. Also, if you look at this, pretty much the same thing's going on over here. You have OJN, um, and you have NJM. Both of those are acute. They appear to be less than 90 degrees, and they are sharing a side. The side would be JN. So OJN and NJM. Next, we're going to identify two obtuse vertical angles. So vertical angles, they need to share a vertex, right? And to be obtuse, it's greater than 90, so we're going to look for our biggest angles. So I see HJO looks like an obtuse angle, and the angle J, or the vertex J, is used for a lot of angles in this picture, but the one that's vertical to it would be KJL. Okay, they're clearly sharing the J. Um, Vertical angles will always have that same middle letter because the middle letter is always the vertex letter. So HJO and KJL are two vertical obtuse angles. You could also say HJN, that's even more obtuse, and KJM. Those would also be acceptable answers, but I just wrote what I said first down. Moving on to part C, it says name the opposite rays in a linear pair. Remember, a linear pair are angles that are adjacent to one another and then they share a flat line, okay? So if I see it changing direction, it's not a linear pair, okay? So we need to name the opposite rays that are in the linear pair. So if I look at JN, it appears to be making a straight line when I combine it with JK, okay? So I would say JN and JK would be my opposite rays. I could also say JH and JM. That would be also an acceptable answer. So I went ahead and I wrote both of those answers down, and while I was doing that, I decided, oh, you know what, I'm just going to add what I previously said about the other one. So yeah, here are all the answers for example one. So I'm going to chop this up into multiple parts. So this is going to be the end of part one, and I'll link parts two and three in the description.